So my name is Vedran Sekara. I am from UNICEF Innovation, and I'll be speaking to you a bit about how we use AI and machine learning for the benefit of the most vulnerable populations. So the UNICEF Innovation, we're a pretty small team. So we're around 35 people. This is us having fun. And what we focus on is technologies, emerging technologies that will have an impact on our lives within the next 2 to 5 years. So we're trying to look into, can we use drones to deliver vaccines? Can we use a blockchain or distributed ledgers to give identity? Can we use AR and VR for education? And also, how can we use machine learning, data science, and AI for benefit of sort of vulnerable populations and sort of in general for the benefit of humanity? So a lot of the work I'll be presenting today is actually done by all these amazing people. We just couldn't fit into a plane, so they just sent me over here. So today, the world is changing. It's not as simple, and the problems we're facing are super complex and very difficult to solve. So one problem is epidemics. Today, the world is more interconnected than ever. So a small disease can nowadays suddenly become into a global pandemic in a very, very short time. We're also facing displacement. So actually last year was a record-breaking year. In total, 68.5 million people are displaced. That's more than the population of UK. We're also facing stuff like climate change. That's sort of pretty self-explanatory. I won't go into that. And also automation. So how can we as UNICEF actually teach kids the correct skills they will need in the future? Skills that won't be sort of made obsolete by automation or AI, such that it can have sort of a good future. So all these are sort of super difficult, complex problems, and we can't really solve them alone. So in UNICEF, we're trying to do two things. The first thing is we have sort of this sort of big data platform, which we call the Magic Box, which is a funny name. I'm not sure how we ended up on that. This was actually the best name we had, believe it or not. Basically, what it does is we found a gap in the market. So we see on one side, we see like humanitarian organizations, and we see also like development sector. We have super important problems we're trying to solve. But the data we're using is not always adequate to do though. On the other side, we see the private sector. They have tons of data, but the problems they're trying to solve, maybe not so important. So basically, what we're trying to do is sort of bridge the gap. How can we sort of use private sector data to actually solve some of the most important problems? So that's where our sort of magic box or our big data platform fits in. But we can't do this all alone. So it's sort of part of a larger ecosystem. So we can't save the world, or we can't sort of solve all these problems ourselves. So we're engaging with academia, we're engaging with the universities, with the researchers, asking them to come help with us, come help us or work with us. Actually, we have asked Ingmar and QCRI to come do small research projects with us. We're engaging heavily with governments and also other international organizations like UNDP and the World Food Programme. We also have a second thing, which is actually we have a venture fund, which is pretty unique in the UN system. It's also a special venture fund. So we give out money to startups, early stage startups. We don't give a lot of money, we give $100,000. But basically, we don't take any equity. So your company is still your own. We only require one thing. And that's basically that everything you do is open source. So if you should fail, we can use your solution later on in time. So these two things combined, our open collaborative big data platform and our venture fund, we use them together sort of to drive innovation. I'll give you sort of two examples of what we do, how we can actually use this. So one thing is, since we're UNICEF, is we always ask ourselves, the question is, where are all the schools in the world? That's a very good question. So we ask ourselves, can we map every school in the world? Can you guess how many schools there are in the world? We have no idea. So so far we have mapped 700,000 schools. We started this 2 years ago. So each blue dot on this map, I'm sorry, it was much more high def on my computer, but each blue dot is basically a school. In some regions, like in South America, we're doing quite well. In other regions, we're not doing so well. But basically, this is really important for UNICEF to know where all schools are. I'll just give you one example here. We started our work in Colombia. So here we partner with 3 private sector organizations, Telefonica, Red Hat, and Facebook, to figure out where all the schools located. So the first step we did was actually just find the schools. So each dot here is a school. We're sharing this, we're actually working with the government, so sharing all of this with the government of Colombia so they can use this to better make policies. And what they're using it for is actually to make contingency plans in case of emergencies. So if something should happen, schools are always very central. This is the center of the community. This is where sort of first aid is sort of delivered from. This is where like vaccination campaigns like stem from. So knowing where schools are is really important. Now what we next did was actually map the connectivity of each of these schools. So do schools have internet? So the colors here, if a school is red, it means it has no internet at all. If a school is orange, it means it has internet, but it's slow, less than 3 kilobytes per second. If it's green, it means it has high-speed internet. So you can see there is actually a lot of room for improvement. So basically, the government of Colombia can actually know if something happens in this region here, we can see these schools are not so well connected with the rest of Colombia, so they might need more help. And they can basically use this to make better preparedness plans in case of emergencies. We also have included here like epidemic risk, poverty maps and stuff like that, but it's not shown here. The next thing, once we have all the location of the schools, so this is an example from Iberia. Can we actually train a deep learning classifier to actually detect a school from space? So basically in Iberia we didn't have all the schools in the country, we had some of the schools. So basically how do we actually scale up this data set? How can we use it to actually get a map of all the schools in the country? Well, we had a partnership with Digital Globe. They gave us access to high-resolution satellite imagery, and we formed 2 partnerships, one with the US San Diego, and one with a company called Development Seed. So together we basically developed AI methods, deep learning algorithms to actually detect a school from space. Now can anybody like tell me what's the best feature to detect a school? Exactly. Playground and U-shaped buildings, and actually also somehow like H-shaped buildings, which is funny. So actually, this was like a first approach. So we have a paper on this. It's coming out. The accuracy isn't amazing. It's around 80%, but we're working to improve it. But actually, you can detect schools from space. The next thing as we did is also, as UNICEF, we're really interested in sort of how do we sort of structure and how do we sort of deliver, so how do we allocate resources? So we always want to know, can we map socioeconomic indicators globally? And the question is, can we draw, just simple question is, can we map poverty? That's sort of the first step. Does anybody know how to map poverty, like from the beginning, like how it's done now? No, just the simple. So basically, surveys, right? This is actually a real survey, a question. So what you do is you hire a lot of people. You train them to ask the correct questions. So you can't ask questions like, are you poor or are you rich? Or how much money do you earn? You ask questions like, how much money did you spend last month on food? Or do you own a car? Do you own a radio? Or do you own a TV? Based on these questions, you can sort of figure out this person or this household is wealthy or less wealthy. And sort of to get a good sample, you sort of send out people to knock on doors of 20,000 households, 50,000 households, sometimes even 200,000 households. So this takes forever. And this is not the first page. Sorry. This is just the first page. This just goes on and on and on and on. So this is actually a lot of questions, and usually it takes sometimes 2 to 3 days. And maybe you even have to come back next week to actually have a follow-up schedule. So basically, this emoji, sort of how it feels like. It's very slow, but you get really good data. But it takes a long time and it's very costly. So can we do this in a sort of a bit of a smarter way? So here we have, again, 2 projects. I'm just going to showcase those. So the first thing is actually a project we partner with the MIT Media Lab. And partners, sort of basically the group is called Human Dynamics. They have a partnership with Global Pulse, and basically what we did is we took Twitter, it's the easiest social network that's available, and basically asked the question, can we use social media data to map poverty in the country? So we're actually doing this for 10 countries. I've just zoomed in on Mexico here. And basically what it turns out, we can actually, using machine learning, pretty easily not get the best model. We won't have 100% predictability, but we can have a pretty good, we can explain around 75% of the variation using a super simple model and using just Twitter. I, of course, have to mention that social media data is not representative of the most vulnerable or of the poorest people, but actually it works okay. So the next step in the process is, how do we improve it? Can we somehow combine data sources? So here we have a partnership. Actually, we funded a company through our venture fund called Thinking Machines. They'll present later today. Isa sits here. And also, we're trying to combine it with social media data. And this is where we have a working sort of collaboration with Ingmar and QCRI. So how do we actually combine satellite images to detect poverty from space with the social media data? This is still work in progress. But it's turning out, it looks to be very promising. This is, of course, not all the stuff we work on. We do a lot of other different things. So we're looking into how can we actually map migrations, how can we map crops, can we do it from space, can we predict the productivity of a field 2 months in advance, such that we can sort of figure out, will there be a hunger? How can we sort of prepare for that? We're also mapping populations. We have this project called Information Poverty. So I'm sure every one of you knows that for a child to be to survive, it needs around 1,500 calories per day. But how many kilobytes do you need to have a good life, to be able to learn? So that's what we're trying to quantify that. We're also looking into epidemics, detecting informal settlements again from satellite images, looking at natural disasters. Can we figure out how fast the community recovers after a natural disaster? We're also using AI for this. And then again, of course, looking into data bias and algorithmic bias. So how can we as UNICEF sort of try to adapt our techniques such that we have an equitable solutions? Now, to do so, we have to partner with a lot of people. I won't go through all of these partners. But basically, we see that there are a lot of different opportunities to partner with us. One is just simple data partners. So you give us data, we work together. Other partners are, you can give us money and we can do a project together. Or we can also we ask for research, for competencies, for researchers to work together. In some cases, we actually get all three from a partner. Depends a bit from partnership to partnership. But we have different partners, like from private sector companies on the left, to we have universities, UN groups, even have organizations such as the European Space Agency on our side. But we, of course, we're in need of more friends. And we're always looking for new partners. So basically, we need friends. Again, looking for data, looking for funding, looking for research partners to bring AI to the most vulnerable and help us to develop technologies that can be used for everybody. Ingmar, how much time do I have? Perfect. So, again, I'm from UNICEF Innovation. I've added 2 links. I'm thinking these slides will be shared. You can read more about this on our web pages. And actually, just one more thing. We actually have an open call for proposals. So if you have to have part of that venture fund, and if you know somebody who's looking for or who has a startup that does AI, we'll happily learn more about them, maybe give them funding. That's it.